everyone, my name is Amorita with student ID 2024-32051. In this video, I will explain an intrusion detection system IDS practical session with two different methods, is port entry and Corey honeypot. So let's begin with the implementation of port entry. Okay, before we starting the practical session, I changed adapter 1 in VirtualBox to host only adapter. This configuration allows the Windows machine and Kali Linux virtual machine to communicate within the same virtual network without requiring an internet connection. Next, I verified that both devices were successfully connected. On Kali Linux, I displayed the IP address using the IPA command, and then from the Windows machine, I sent a ping request to that IP address to press to the reply from message confirm that the network communication was successfully, allowing us to continue with the practical session. Next, after confirming the network connection, the next step was configuring port entry, and I opened the configuration file using the nanotext editor that enable monitoring for both TCP and UDP protocols. And the settings allow port entry to detect different types of port scanning activities that may be performed by an attacker. Once the configuration was complete, I start the port entry service using the command systemctl start port entry. Next, I enable the service with systemctl enable port entry, and this ensures that port entry starts automatically every time the operating system boots and continuously monitors network activity. Next is simulating a port scanning attack. And at this stage, I simulate a port scanning attack using Nmate from the Windows computer, and I use the SS option to perform TCP SYN scan and the PN option to skip host their discovery and begin scanning immediately. After the scanning process was complete, I checked the port entry logs using journalctl command, and the logs show the IP address of the scanning device along with the exact time the scanning activity occurred. And these results confirm that port entry successfully detect the port scanning attempt. And based on the testing results, it can be concluded that port entry is capable of detecting reconnaissance activities and especially port scanning before an actual attack takes place. And this early detection provides valuable information for network administrators, allowing them to preventive actions before more serious attacks occur. And now that have seen how port entry detects port scanning activities, so let's continue with the implementation of Corey honeypot, which functions as the decoy server designed to record and analyze attacker activities. Okay, so before we starting the honeypot practical session, adapter 1 in VirtualBox was changed to bridge adapter, and this configuration allows Kali Linux to obtain an IP address that can be accessed directly from the Windows computer and enabling as SSH connection during the testing process. Next, I create a dummy user account using the @user command, and this account will be used specially to run the Corey service and ensuring that the honeypot operates separately from the administrator account for better security. And after that, I move to the OPT directory, and which is commonly using the to store additional applications on a Linux system. Next, I downloaded the Corey source code from GitHub, and Corey is a honeypot capable of emulating SSH and Telnet service, making attackers believe they are accessing a real server. After the installation process was complete, I used the ls command to verify that the Corey directory had been successfully created, and the presence of this directory indicates that the installation process was successfully. Next, I grant the dummy user ownership and permissions for the entire Corey directory, and the step ensures that the dummy user has the necessary permissions to run and configure all Corey components without encountering permissions issues. And after granting the required permissions, I switch the dummy user account, and this allows all honeypot activities to run under the separate account instead of the administrator account, and improving overall system security. After successfully logging into the dummy user account, I return to the Cori installation directory using the cd opt Cori command to continue the configuration process. Next, I create a Python virtual environment so that all libraries required by Cori will be isolated from the main operating system. And after creating the virtual environment, I activate it to ensure that all required package will be installed within this isolated environment. Next, once the virtual environment was active, I install all the required libraries list to in the requirements.txt file, and this library is necessary for all Cori features to function properly. Next, the next step is I perform an editable installation. So this method allows configuration change to take effect without reinstalling Cori whenever modifications are made to the source code. And after that, I copied the default configuration file to create a main configuration file named cori.cfg, and this approach preserves the original configuration file, making it available as a backup in case any configuration errors occur. After successfully creating the configuration file, the next step was navigating to the configuration directory using the cd opt Cori etc command, and the etc directory stores all Cori configuration files, making it the location where all system settings are managed. Next, I open the Cori CFG file using the nanotext editor, and this configuration file, I change Cori's service port from 2224 to avoid conflicts with other service and simplify the testing process. And after completing the change, I save the file by pressing Ctrl O, and then exited the editor by pressing Ctrl X. And after completing the configuration, I returned to main Cori directory and started the service using the bin Cori start command. And at this stage, the honeypot became active, then was ready to accept incoming SSH connection from other device. Next, I verified the Cori was running properly using the ss command, and if the output displayed the listen status on port 2224, it confirmed that the honeypot had been started successfully and was ready to receive incoming connections. Next, I display the Kali Linux IP address using the IP command, and this IP address will be use the destination for the SSH connection from the Windows computer. And after obtaining the IP address, I test the network connectivity by sending a ping request from the Windows computer, and the appearance of the reply from message confirmed that communication between Windows and Kali Linux is successfully, and indicating that the honeypot was ready for testing. Next, I navigate to the var log Cori directory, and which stores all activities recorded by the honeypot, and this directory contains important information such as login attempts, source IP address, and user activities during each session. Next step, to monitoring the activities in real time, I execute the tailf Cori.log command, and this command continuously displays new log entries as they are generated, allowing the administrator to observe every incoming connection immediately. And after enabling a real-time log monitoring, I simulate an SSH login from the Windows computer and to the honeypot server using port 2224, and Cori displays an environment that closely resembles our real Linux server, and making users believe that they have successfully accessed an actual system. Okay, during the login session, Corey automatically recorded all the activities into its log files, and the recorded information includes the search IP address, the username entered, the authentication process, and all activities performed during the SSH session. And based on the testing results, the Corey honeypot successfully accept SSH connection through port 2224 and recorded all user activities into its log files. So based on the practical session, it can be concluded that port sentry function as an early detection system capable of identifying port scanning activities before an actual attack occurs. Meanwhile, Corey honeypot server as a decoy server that records all attacker activities and allowing administrators to analyze attack patterns in greater detail. And by combining port sentry and Corey honeypot firewalls and continuous log monitoring, network security can be strengthened through multiple layers of defense that complement one another. And that concludes this practical demonstration of the intrusion detection system using port sentry and Corey honeypot method. So thank you for watching and see you in the next video.